Hi there guys, today I want to talk to you about how to use SDA and SCL with your Arduino projects, and in this case we are going to use monitors or screens if you want. I have a couple of these small OLED 0.96 inch two-color monochrome monitors or screens if you want. I also got one of these liquid crystal monitors or displays if you want. However, this one is actually on I2C, while this one is a old school serial connection. If you remember, these old school serial connections have 16 pins hooked up to them, and you need them all. While with this I2, I only have 4 wires connected and 2 of them are power. So in reality, I'm only using 2 wires. That's pretty cool. I2 is a modern standard used, well, it's not really that new, but it's a new standard used to communicate between, and you can see on the screen, it says master. In our case, our master is the Arduino, and different units. It doesn't have to be monitors, it can be sensors, anything really that is designed to work as a I2C module. And that means I can hook up this liquid crystal screen, this one, maybe 10 of these to the same 2 wires. And in our case, Arduino will still only need 2 wires to communicate with them all. And that's pretty amazing. There are some downsides to it, because I think the limit is 256 units, and we're not going to need that, so that's fine. However, the way it works is the master is actually going to ask these one at a time, do you have anything? Or in another situation, the master is going to send a signal to one of the devices and say, did you get the signal? So slave 1 will get a signal and it will answer. Slave 2 will get a signal and it will answer. Slave 3, and so on. That means it could potentially cause lag, stalling your system if you are putting up a lot of devices, or if one of your devices is having some sort of error or problems, and it could cause a delay. That's something you can program your way out of. You can put a timeout on these devices, so if the time is more than 10 milliseconds or whatever you define, skip on to the next unit. So let's see how they actually work. Right now I'm using this Arduino with a liquid crystal display. It's a 16:2, and I got my name shown at the top, and I got a scroll text at the bottom. This particular unit I had a lot of problem with, because I imported this translation module from China, and these pins are not in the correct order. Luckily, there was a guy on the Arduino forum. He was able to uncode this, and this was actually 2 or 3 years ago, but I still find it relevant, because I bought this in, well, what's November 2014, and they are still wrong. So this is not just something that happened a long time ago. They are building them differently than we use here. And I live in Denmark, so a lot of us is European standard, and they remind a lot of American standard. However, the Chinese standard apparently is completely different than anything we use. So we have to consider this when designing our software and using Chinese components to communicate with our software. This is nice. Well, the first thing you want to do when you get such a unit, these I2C units, you need to know the address. Many of them have the address actually printed into them on the back of the unit. However, just like this one, it says address select, and there is a resistor and 3 bars, and the resistor is connecting 2 of them. That means if we look at this, for these units to work, they need a unique identifier, a unique address, and it's a MAC address, 1 byte MAC address. So it actually says on this one 0x78, and this is wrong because that's not its address. And I'll show you that right now. So I'm just going to unhook my Arduino. I got 2 power wires and 2 wires connected to the SDA and SCL. And I'm going to hook it up to the matching wires. It's written on top of this device. So give me a second. There we go. Power and ground. And the SCL is the white. So let's do that. There we go. It's hooked up. And of course, I'm powering it now, or at least I thought I was. Oh, yeah. So, when you do like me and you short circuit your component, not a good idea. There we go. Let's try that again, shall we? Oh, and by the way, that's a Chinese Arduino, and it didn't take damage from mispower. So that's actually quite impressive. Anyway, the monitor might have taken damage, but we'll find out in a minute. It's hooked up now correctly, and there's nothing on the screen, and there shouldn't be, because we are sending data to this address. So this should have a different address. In fact, it does, I know. But in order to find the address, I could use some software and write this address down that says 0x78. And the other address I can use is 07A. So shouldn't the other one be a B? But hey, guess not. Got the software. It's called I2C scanner. It's on the official Arduino phone. I'm just going to upload it as is, not changing anything. And you can see it's just compiling. Give it a few seconds. Uploading, done uploading. There we go. Let's watch the serial monitor. It's going to scan the network, and we got an address called 0x3C. That's not what it says here. That is why it's very important to scan your new units. Okay, these can hot swap, so I'm just going to unhook it, and they don't match directly into the other one. So you have to really pay attention to white is SCL. So let's do that. Yeah, they are actually opposite, and we got the purple to ground. Let's not repeat the success from 4. And if you watch the screen, you can see there are no I2C devices found. So let's hook up the power. That's the last pin we need. And it lights up. Device found. It actually found 2 devices. Check that out. Let's give it a second to think about that. Scanning. And nothing. I'm going to reset the Arduino because that might have been a short circuit. There we go, scanning. 0x27, that's the actual address. I think that 65 is a bug, and it was caused by me messing around with the pins while it was powered. So we got these 2 addresses. We got this one called 3C, which is not mentioned anywhere on this device, and this one is called 27, and it's also not mentioned anywhere. Even if it was mentioned, it might not even work. Okay, now we know the unique names and identifiers of our units, and we can get into using some software. So we got our LCD hooked up first, so let's use that first. As mentioned, the pins are wrong. On the official Arduino forum, there's a guy a couple of years ago who actually worked this out, and I told you this before, but it's very important. If you hook it up without using the way you using the software as intended, you'll just get a blinking or a black screen. It won't work, and you'll think, is it broken? Well, usually not. They are actually very hard to break. The code is in the official form. I just searched for blinking LCD, and you can see this small device, I2C device, has a identifier. It's called UC146, and I searched for that in the same line, and I got this code we got on screen. And I read the post, and they explained that the pins are wrong. You can see the reverse pin, rewrite, sorry, we pin D5, 4, 5, 6, 7, and how they are defined. They are the same, but you can see these are reversed. So some of the pins are reversed. Luckily, you can just change it through the software, and that's that's good. So all I did was enter my name in a string. I just named it still string, and I found some scroll text on the web, just ordinary C code, and made another string with some numbers in. And that's it. Let's upload it. All it's doing in this loop is just holding the top line still while printing the lower line over and over and over. So it's a dirty hack, but it's going to work as soon as it's done uploading. Uploading now. Get some flashing. There we go. Screen turns off and on, and it's working. You won't be able to see it because of the LED light, but it says my name at the top, and it's scrolling the text below. Very cool. I'm just going to unhook it. There we go. And I'm going to unhook my Arduino. So let's try the same thing with the small OLED display. And let's see if we can hook it up this time without messing it up too much. There we go. And the white one is SCL again. So, same connection as with the LCD. I'm going to power it. Of course, it's not going to work because, first of all, we scanned the address. The address, you can see it's right there. It says 27. That only matches this device. This device has an address called I2C. So there's no image on it. Luckily, well, another thing, reason it won't work is because the library we're using right now is a LCD liquid crystal library. It's not going to work with a LED monitor or screen. But Adafruit has a very nice library for these small devices called SSD1306. You can see we got it right here. The library have a lot of examples, and let's see examples. You can see Adafruit. You have to choose the right one. Now I know from the company specs that this one is a 128 times 64. So that is the example I'm going to use right here. I have the example right here, except I've cut everything out I don't need. Well, these two libraries I don't really need either because we're not using SPI and we're not using wire. We're using Adafruit libraries, and that's it. And we define our address right there. As you can see, it says OX3C. And there's nothing in the main loop. We just end the setup by main display function. That's this one here. And we're just using it just like you would a serial, except we add display in front. So it says display set text size, display set text color, except you can't set colors on these. These are monochrome. I'm going to hit upload. But what you can do is you can inverse it. So you can have a black screen with colored letters. That's what we normally do. And you could inverse it and have a colored screen with black letters. I don't like that. And there we go. It doesn't matter what I say, but the point is it's working. Now, if I wanted these two to work together on the same two wires, just like this drawing says they should be able to, I'm going to need more memory for this unit because this Arduino is not able to hold all these libraries. So that's where our limitations come into hand. You can work around this by excluding everything you really don't know or using multiple Arduinos and use the shared communication. However, I think that's all I wanted to say about the SCA and SCL, or if you want, I2C communication with, well, in our case, just a couple of displays, but in reality, you can get sensors and all sorts of devices to help you in this process. Thanks for watching, comment, rate, and I'll see you next time.